Traditional swing check valves are utilized for dirty water under generally lower flowing conditions. As our pumping systems have evolved through time, we've come up with, or we now experience, higher pumping rates and more modern trash that can impose problems. Welcome to the rubber flapper check valve. Whereas traditional swing checks still have their place in the marketplace, flexible rubber disc check valves have softened the blow to difficult conditions. Traditional swing check valve is going to have a vertical arm on a hinge pin on the inlet side of the valve. You'll notice with this style valve, this is the Flomatic model 745 with some added features. Our seating surface is on approximately a 45-degree angle. Water hammer is the result of reverse flow, the system absorbing the pressure surges upon pump shutdown, power failure, whatever the case may be. We need our check valve to close before that reverse flow comes back to the system. Where that traditional check valve has a vertical arm and travels up approximately 90 degrees, it has a generally long distance to travel from full open to full close. The rubber flapper check valve on that 45-degree slant seating surface has approximately 35 degrees of travel to full open. The geometry of this valve is such that we still have a full open waterway and can handle the full flow of the system. This valve, like a traditional wastewater check valve, can handle large solids of the pipe size, can handle those flow conditions, and we now have a rubber flexible disc versus a hinge shaft. As I mentioned, water hammer, the faster we're flowing, the quicker that surge can return and the more amplified that surge can be. So whereas a typical swing check valve, perhaps with a weighted arm or a springed arm, can handle flows maybe up to 6 feet per second. The standard base model on this valve I would be comfortable with maybe up to 8 feet per second, depending upon the system dynamics. We get above and beyond that, we have some additional features that we can add to our Model 745 to make it into our Model 745 surge stopper. You'll notice on top of this disc, there is a metal plate, if you will, metal spring. Similar to a mousetrap spring, that spring will quicken the velocity at which this valve will close. The quicker this valve is going to close, or the quicker that any valve is going to close, the better opportunity we have to protect our pumping system, our pipes, and our joints from destruction. So why is surge protection important? First and foremost, we can have catastrophic damage to our pumps, our pipes, and our system as a whole. This would result in costly downtime and high maintenance on the system. These surges can occur anywhere we're pumping. We're putting energy into the media that we're moving, and that energy needs to be absorbed when the pump shuts down or there is some sort of failure in the system. This can occur in pressurized systems, whether it be wastewater applications or potable water applications, and it can also occur in open-ended pipe. As weird as that may sound, there is still going to be an amplified surge on pump shutdown with an open discharge system. Generally, we're going to be pumping at a much lower flow rate in a wastewater application. As we get into stormwater and potable water applications, generally that velocity is going to increase with our systems. That is where the spring added feature of the surge stopper could come into play. We can also tie this valve with added features such as our position indicator and our limit switch back to a SCADA system to communicate with your overall system parameters. On the bottom side of the valve, there is a port, in this case here it's plugged, such that if this is used in a wastewater application, we can thread in a backflush device, which is basically a rod that would come up and push against our disc to allow this valve to open and backflush through the valve to our pump vault for flushing instances and service and maintenance on your wastewater applications. This valve is constructed of ductile iron, fusion bonded epoxy coating, all 316 stainless hardware. The rubber flapper has a metal disc that's encapsulated with a Buna. There's a reinforced hinge so that as this disc flexes, there's minimal memory and will close every time. Also to point out, on the seating face of the disc, there is a raised rib that allows for more of a positive closure on the valve seat when this goes to the full closed position. Our surge stopper is available in our AIS and BABA compliant version model 745, and a size range from 3-inch to 12-inch. Lay lengths of this valve will comply with the requirements of AWWA C508 for swing check valves. Dimensionally, this will meet or could replace a traditional swing check valve in the field. This is one of the few spring-assisted versions of a wastewater check valve on the market. It can be installed in either horizontal flow conditions or vertical flow up conditions. In vertical flow up, I highly recommend the spring to ensure that this disc closes quickly and positively. Again, it can handle high solids content, slurries, mining, any application you can think of. It is important to point out the higher the solids content and the higher that we are flowing, we're probably going to wear this valve out quicker than under a normal wastewater application. However, can still handle those medias in a great fashion. Some places these valves may be used other than in your potable water applications could include irrigation systems, booster pump stations, as well as water well systems with submersible pump compatibility. When it comes to wastewater, you might see these in wastewater lift stations, municipal sewage stations, perhaps for flood control or stormwater management, as well as in chemical processing, food and beverage, and mining and slurry applications. For any questions, please contact our friendly and helpful customer service or technical support staff, and we'll be happy to help.